Let us learn about units. Physics for everyone welcomes you. And let us learn measurement, physical quantity, units, fundamental quantities, derived quantities, different unit systems, SI system of units, the advantages of SI system, unit prefixes, and finally some common practical units. All these small topics we are going to learn in this session. Let us start with units. Measurement. Here, what you see? A tailor tailoring a shirt by taking a measurement. If he goes wrong with his measurement, definitely the shirt will not fit for this man. So let us learn the definition. The comparison of any physical quantity with its standard unit is known as measurement. The comparison of any physical quantity with its standard unit is known as measurement. Physical quantity. Measurable quantities are called physical quantity. Whatever you measure, that quantity becomes a physical quantity. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. Examples are length, mass, time, force, energy, etc. Physical quantities can be classified into two types. One, the fundamental quantities, next, derived quantities. Let us learn about these fundamental quantities and derived quantities. Before that, let us learn the unit. A unit is a standard quantity with which the unknown quantities are compared. A unit is a standard quantity with which the unknown quantities are compared. Like 1 kilogram, how many multiples of 1 kilogram will give the mass of a given body? Right? 1 meter, how many multiples of 1 meter will give you the length of the rope? Good. So let us go further. It is defined as a specific magnitude of a physical quantity that has been adopted by law or convention. It is defined as a specific magnitude of a physical quantity that has been adopted by law or convention. For example, meter is the unit for measuring length. That means 10 meter is equal to 10 times the definite predetermined length called meter. Here you have a tape with 3 meter. So here the length of this 3 meter tape is 3 times of 1 meter. Fundamental quantities. The physical quantities which are independent are called fundamental quantities. Like length. Length cannot be measured by any other physical quantity other than meter. Right? This is independent quantity. We will be learning step by step what are the 7 fundamental quantities, and finally you will know what importance you can give it for these fundamental quantities. The units of fundamental quantities are fundamental units. Example, length measured in meter. Right? Here a small piece is measured with the help of the length is measured with the help of the vernier caliper. Second, the mass. The mass of a body is measured by a physical balance, right? And it is measured in terms of kilogram. The unit of mass is kilogram. Time. The time between the two events, what is lapsed is the time. It is measured by second. Then electric current, that is measured by a meter called ammeter that measures how much current flows through a conducting wire in a circuit. Temperature, it is measured in terms of Kelvin. Amount of substance, here the amount of substance is the number of entities in the 1 mole or in the given amount of substance. In the first balance there are 2 molecules of ozone, good, and in the second pan you have 3 molecules of oxygen. So in left and right pan there are totally 6 numbers of oxygen atom. Good. So same mass, different amount of substance. On the left pan, only 2 molecules are there. On the right pan, there are 3 molecules are there. And in the second diagram, in the second picture, right, different masses, but same amount of substances. On the left and right pan, only one molecule is placed, but they are of different mass, right? So here comes you understand what is amount of substance. The unit is mole. Luminous intensity measured in candela, right? Here the flux, the light flux through one stadian angle is called the candela. This is the only one fundamental quantity that is measured with the perception of human eye. Derived quantities. The physical quantities which can be expressed in terms of fundamental quantities are called derived quantities. The physical quantities which can be expressed in terms of fundamental quantities are called derived quantities. The units of derived quantities are derived units. Example, plane angle measured in radian, right? The arc length is equals the radius. Then the angle subtended at the center of the radius gives 1 radian. Plane angle equals arc divided by radius. Second, solid angle measured in stadian. Here you have a sphere, right? There is a cone here. The cone angle at the center, right, with the area r square gives 1 stadian. Solid angle equals surface area divided by r square. Area meter square. Here the surface area of a square is a square. For a rectangle it is BH, and for circle it is pi r square, and you have the triangle, area of a triangle equals BH by 2 of BH. Then volume, it is measured in terms of meter cube. Here you have different shapes with different formulae. The volume of a sphere is 4 by 3 pi r cube, but in terms of diameter it is by pi d cube by 6. And the volume of a cube is a cube, the sides cube, right? Here you have a cylinder. The volume of a cylinder is pi r square h, but in terms of diameter it is pi d square h by 4. And you have a rectangular prism and a cuboid. Its volume is ABH. Good. Here you have a car that goes from A to B in 2 different routes. One is straight, the other one is a curved one. The straight in a single direction is called displacement, and the curved one, okay, it can have any number of route. Okay, depending upon the route, the distance vary, but not the displacement. You learn about distance, displacement, velocity, speed, acceleration in detail in your next chapter. Let us go with only the formula. Velocity equals displacement by time. Its unit is meter per second. Right. Good. Next, speed. Speed equals distance by time. Its unit is meter per second. Acceleration. Acceleration equals change in velocity by time taken. Its unit is meter per second square. Then finally the force. Its unit is Newton. Newton can be written as kilogram meter second power minus 2. The formula for force equals mass into acceleration. Different unit systems. Different countries followed a different system of units. Later, all these are removed and we started following SI system of units throughout the world. System. CGS, system of units. In that, the length is measured in centimeter, the mass is measured in gram, and the time is measured in second. The second system is FPS. In FPS system, the length is measured in foot, mass is measured in pound, and time is measured in second. And here the third system, MK system, in that the length is measured in meter, the mass is measured in kilogram, and the time is measured in second. Good. These 3 systems in different parts of the world confuses the scientists. So all the scientists get together and finalized one single system of unit, that's called SI system of units. Right. SI system of units is the modernized and improved form of the previous system of units. It is accepted in almost all the countries. The advantages of SI systems are: 1. This system makes use of only one unit for one physical quantity, which means a rationalized system of units. Suppose you consider heat. Heat has different units. One is calorie, the other one is joule, then electron volt, like that. But here, if you come for SI system, for heat there is only one unit called joule. In this system, all the derived units can be easily obtained from the basic and supplementary units, which means it is a coherent system of units. Right? Let us learn this with an example. The SI unit of power is watt. Power equals work done by time. The work done by time. The work is replaced by force multiplies the displacement. Good. Now the force is replaced by mass into acceleration. Once again, the acceleration is replaced by velocity by time. Good. Once again, the velocity is replaced by displacement by time. Right? So here you have power equals, right, mass multiplies displacement divided by change in time. So let us write the left hand side unit is watt, whereas the right hand side unit is kilogram meter square second power minus 3. That's what here is given in the second point. In this system, all the derived units can be easily obtained from basic and supplementary units, which means it is a coherent system of units. The third one, it is a metric system, which means that multiples and submultiples can be expressed as the power of 10. Look at here. 1 meter can be written as 10 power 2 centimeter, 100 centimeter, right? The same 1 meter can be written as 10 power minus 3 kilometer. This is what here mentioned. It is a metric system, which means that multiples and submultiples can be expressed as the power of 10. Unit prefixes. Unit prefixes are symbols placed before the symbol of a unit to a specific order of magnitude of the quantity. Unit prefixes are the symbols placed before the symbol of unit to specify the order of magnitude of the quantity. They are useful to express very large and very small quantities. A unit prefix stands for a specific positive or negative power of 10. Let us now start. 10 power 15 equals peta. The symbol is capital P. Good. 10 power 12 is tera equals capital T. 10 power 9 equals giga equals capital G. 10 power 6 equals mega equals capital M. 10 power 3 equals kilo equals small k. 10 power 2 equals hecto equals h. Then 10 power 1 equals deca equals dA. 10 power minus 2 equals centi equals c. 10 power minus 3 equals milli equals m. 10 power minus 6 equals micro equals mu. 10 power minus 9 equals nano equals n. 10 power minus 12 equals pico equals p. 10 power minus 15 equals femto equals f. Some common practical units not in SI units. Distance. Light year. It is the distance travelled by light in vacuum, that is at a speed of 3 into 10 power 8 meter per second in 1 year. 1 light year equals 3 into 10 power 8 meter per second. This is the velocity, multiplies the time. Time has to be written in second for 1 year. So 1 year contains 365.25 days, and one day has 24 hours, 1 hour has 60 minutes, and 1 minute has 60 seconds. If you multiply all these values, finally we get 1 light year equals 9.5 into 10 power 15 meter. A space shuttle in space travels at 8 km per second, then it takes 37,000 years to travel this distance. Then imagine how long this 1 light year distance is. Astronomical unit. It is the mean distance of the sun from the earth. One astronomical unit equals 1.5 into 10 power 11 meter. Parsec, parallactic second. 1 parallactic second equals 3.26 light year equals 3.08 into 10 power 16 meter. And one more. 1 micron equals 10 power minus 6 meter. And one more. 1 angstrom equals 10 power minus 10 meter. 1 Fermi equals 10 power minus 15 meter. Mass. 1 quintal equals 100 kilogram, and 1 metric ton equals 1000 kilogram. And 1 AMU, 1 atomic mass unit equals 1.66 into 10 power minus 27 kg. Then the time. 1 day equals 86,400 seconds, and 1 year equals 3.156 into 10 power 7 second. Thank you, children.